Calculating the Laplace transform is one of the most important topics in signals and systems. It contains many subtle points and useful tricks. And in this video, we want to cover those details by solving this example step by step. The signal xt is given as shown, and our goal is to find xs. Before solving the problem, let's quickly review a few important properties. The Laplace transform of e to the power of minus at ut is 1 divided by s plus a, with the region of convergence, real part of s greater than minus a. Also, the Laplace transform of minus e to the power of minus at u minus t is again 1 divided by s plus a, but with ROC real part of s less than minus a. The third property is the differentiation property. If xt has Laplace transform xs, then xt has Laplace transform minus derivative of xs with respect to s. Now let's solve the problem. First, we remove the absolute value of xt. For positive values of t, we write the signal as shown. And for negative values of t, we write it as shown. Now we can rewrite the first part as t e to the power of minus 2t ut, and the second part as minus t e to the power of 2t u minus t. Therefore, the signal xt can finally be written in the desired form. Now let's calculate the Laplace transform of the first term. Using property 1 and the differentiation property, we can write minus derivative with respect to s of 1 divided by s plus 2. Here a equals 2, and ROC will be real part of s greater than minus 2. Now taking the derivative of numerator times denominator minus derivative of denominator times numerator divided by denominator squared. Since the derivative of numerator is 0 and the derivative of denominator is 1, we finally get 1 divided by s plus 2 squared with ROC real part of s greater than minus 2. Now let's calculate the second term. First, we factor out t and rewrite the expression as shown. Then, using the second property and again using the differentiation property, with a equals minus 2, we can write minus derivative with respect to s of 1 divided by s minus 2. Again, using the derivative formula, the Laplace transform of the second term becomes 1 divided by s minus 2 squared, with ROC, real part of s, less than 2. Therefore, xs can finally be written as shown. Now the only remaining task is determining the overall region of convergence. From the first term, we had real part of s greater than minus 2. And from the second term, real part of s less than 2. We net the intersection of these two regions. Therefore, the final region of convergence is real part of s between minus 2 and 2. We have solved many similar examples on this channel as well. If you found this problem useful, please like the video, subscribe to the channel, and follow our other tutorials.